Hello and welcome to Proxys webinar, today on topic plant-based drinks and other dairy alternatives. My name is Lubos Petrashko. I am a product manager at Proxys and I have an opportunity to moderate this session, partially present a couple of things. The main part will be covered by a experienced application specialist, my colleague that accepted the invitation to present the topic, Mr. Mark Köstlin. Hello, Mark.
Hello and hello audience. Thank you for the brief introduction. I will guide you through most of the slides, focus on processing, and my background is a food technologist, and I wish you a pleasant stay here in this format.
Thank you, Mark. So for today, we have focus on two main topics, so plant-based drinks, plant-based yogurt and ice cream. We'll talk about raw materials, difference between animal-based and plant-based products, the way how the raw materials can be processed, pre-processed, what the differences between individual materials are and what their impact on the whole process is. And then we go through more complex processes of how to produce the milk, yogurt, ice cream, and show you where our technology can support you by your products. We have scheduled a 1.5 hour for this webinar. I would like to inform you we are recording this webinar, and that's one of the reasons why we won't be able to bring you forward to ask or voice your question. So I would like to kindly ask you to enter the questions in written form into the Q&A function of the Zoom. We will come to your questions at the end of the presentation. And this webinar, as mentioned, the recording is will be used as for the participants that would like to either watch it later on or missed the event to make it available on demand. So if you haven't heard or are not acquainted with the company Proxys, the Proxys has been founded in 2015 by uniting products, expertise and know-how of three well-established, strong leading brands, which is Prima Koruma, Stefan, and Terlet. Our vision is to support customers with their individual needs, individual requirements, and become a agile and reliable partner for them. This webinar is one of the plenty of webinars that have been planned for this year. If you happen to miss the past webinars, please feel free to contact us by writing us an email onto events@proxys.com, and we can make the webinar available to you on demand. In September, October time, we have following webinars planned, which concern ready meals, different turn on vegan yogurt, quark, cottage cheese, and then in October time, for those that are active in the more sweet applications, very interesting webinar on topic confectionery. Alternatively to webinars, we provide also more intensive form of training with the hands-on approach, practical part as well, and that's a seminar. So if you have a chance to travel to Germany in October and November, there are two seminars planned on the topic mayonnaise, ketchup, sauce, mustards in October, and then in November there will be topics processed cheese, vegan alternative, such as hummus, mayonnaise covered as well. And if you're still looking for additional resource, maybe at your premises or at the time where that suits you better, we can also provide a private form of webinar or seminar. Feel free to get in touch. I think the possibilities are almost endless, let's say. So for today, we have prepared a couple of interactive features in this presentation. And this is the first one of those. So we have a quick poll for you with the question, from which field are you? Just to see who everything is today in the audience, I will switch the poll on. You should see on your screens several options, so feel free to tick one, so single choice in this poll. And I will, after about a minute, I will share with you the results as well to see what is the composition of our audience in this webinar. So the choices we talk about that are available to take consist of food manufacturer of different size, engineering company, equipment integrator, machine manufacturer, or other. So let's see if the selection will stabilize. We are currently at 67%. Let's wait 5 more seconds if somebody wants to enter the selection into the poll. Please feel free to do so. Okay, there is still slight movement. Okay, I believe we are almost reaching 100%. So I will close the poll and share the results with you. So the majority of the participants ticked other, and the second largest amount chose food manufacturer, larger enterprise, so over 250 employees in the company. At the same level, we have participants from machine manufacturer background in call as well. So thank you very much for the participation, and we can carry on with our presentation further. So the plant-based dairy alternatives, but also in this case, in general form, alternatives itself, the growth of the market is propelled by multiple key drivers. I would like to briefly mention a couple of those. I believe some are or have a larger importance in possibly in your region. Some will have different higher importance in other regions. So what certain studies are stating, there is a rising prevalence of restrictive diets among the consumers. Also concerning consumers, the focus on health and wellness is gaining higher attention. And then the consumers are more and more concerned about the food safety. Two more rather social aspects that are propelling the trend are the concerns for animal welfare, as well as a very important one, which is environmental or awareness of environmental sustainability. I prepared a couple of example data. In this case, as an example, how is the situation on the US market? to show you a just rough comparison between animal-based and plant-based products. So on the left side is portrayed a 2-year dollar sales growth of different categories. And as you can see, now talking about the dairy alternatives, cheese, butter, cream and milk, yogurt, all these categories here expressed as a 2-year growth. So let's assume in 1 year is a half growth stated above. Experience comparing to the animal-based products, way faster growth. Looking on the right side, the share of individual plant-based products within the category. So for example, milk, plant-based milk within the whole category of which is composed from animal-based milk and plant-based milk, has already captured 15% of share, in this case on the US market. Similar situation is to be seen in Europe, but other products, they are fairly steady growing and haven't captured similar amount of the market yet. So there is still plenty of potential. Now, a couple of looking at the data from a more protein source that is used to manufacture these plant-based products. It is stated by certain studies that there is a shift between the proteins that have been used previously and that are coming into use in these plant-based products. So based on the Zenith Global, proteins such as soya, rice, almond are becoming more mature markets in this plant-based space. And among the more emerging proteins that are on the rise are peanut, peas, flaxseeds, hemp, rye, wheat, and spelt. So let's look how is the situation among your customers, or based on your experience. I would like to, over the poll, give you the second question to answer, which is which protein source has the highest demand in your field? And so you should see on your screens a choice of 10 different protein sources. Feel free to take multiple. In this case, you can choose as many you consider being of highest demand. And same as before, I would like to share with you the results. Let's see how this poll will turn out. So we're reaching about 44% participation. Let's give it 15 more seconds to reconsider the choices. So we are around 64% of participation of this poll. Okay, maybe 5 more seconds. The number seems to stabilize. There is still some motion. Okay, so I would like to close the poll. I think we are at 66%. So let's see the results. Very interesting. So the main selection based on audience today is the soy as a protein source. Then the second one, also scoring the highest, almond, and then consequently oat, rice, and pea. So thank you very much for your input. And I would like to pass the word to you, Mark.
Okay, thank you, Luboš, for the first part here. Now I will take over with the next slides. So yeah, the next chapter is about plant-based milk alternatives, or also called plant-based drinks. So it is not allowed in most countries to call the alternative milk. This is why usually it is a plant-based drink and not a milk. But as you know, we try to come as close as possible with the alternative to the classic product. And what you can see here is a typical definition of a dairy milk in comparison to a plant-based milk alternative. So as you all should know, dairy milk is a opaque white fluid, which is rich in fat and protein. And it's not only from the cow, it's also from other mammals, from other animals, and it's used for the nourishment of the young. And the humans are the only beings who are using milk from other animals for feed themselves. So this is a quite untypical thing in nature, but yeah, over the years it developed. And physically, it is an oil and water emulsion where all oil droplets are quite finely dispersed in an outer continuous phase. It is also, so the classic milk is also a natural product, which usually does not contain any food additives. Compared to this, the plant-based alternative is a manufactured non-dairy beverage made from water-based plant extracts. And there are several plant extracts which can be used. We will on the next slides go a bit more in detail on that. But what we can say is that we need several processing steps in order to achieve a comparable mouthfeel and structure like the dairy, the classic dairy milk. And yeah, plant-based milk contains insoluble fibers, for example, and most of these alternatives needs to be stabilized by adding specific additives like emulsifier, stabilizer, or also artificial oil in order to get the structure and the mouthfeel to be comparable with the dairy milk. This slide here should show you the structure of our presentation. So we start here with the raw ingredients for the alternatives, which are mainly nuts and seeds, or also different type of grains. And as you can see, these are quite big particles, and you don't want to find them in your milk alternative. So we need to somehow transfer them into a paste, for example, or a so-called slurry. From there on, from this pre-processed mass, we need to do some more modifications with it. Some more manufacturing techniques has to be implemented to reach the milk alternative or the plant-based drink. And finally, there are also other dairy alternatives which are using the milk as base in order to get a structure, as you know, like a yogurt, for example, a fermented product, or an ice cream. This my colleague Luboš Petrasko already discussed with you. There's a growing demand of different alternatives in the market, and this should just show you as a picture how big the variety is of those drinks. So we have different brands, we have different sauces, we have soy, we have almond. You can see on the left side even a mixture between coconut and almond. So there's a huge range, and it's always, or it's still growing. Okay, starting with the raw materials. First of all, we would like to show you the nutritional values of different nuts. So these nuts, as you can see, so we brought 5 different nuts with us, and these having quite good nutritional values in order to transfer them into a milk-like drink. For instance, we have a quite huge amount of protein as a source in all of these nuts here. The fat content is quite interesting. So it differs from 44 to 65%. And interesting fact is that this fat here, it's not a bad fat, it's a good fat. And this is due to the fatty acids over here. We have mono and polyunsaturated fats, and they are claimed to be quite healthy. And if you would compare it to a conventional classic milk, there the most is the saturated one. So we are even a bit more healthy in terms of fat. But the fat has not only an influence in terms of the nutritional value, it has also a huge influence in terms of processing them. So in order to transfer the nuts into a pumpable product, into a paste or a slurry, it needs to be grinded. And due to the high content of fat, nuts can be grinded as well dry. So this is the advantage. And also what we can see here, we have a substantial amount of carbohydrates. So with these ingredients, there is not a must to add any artificial nutritional additives to it in order to be like the conventional milk in terms of nutritionals. Having a look at the other ingredients which we listed here, this is more a heterogeneous group, so they differ a lot from each. We have on the left side soy with a relatively high protein content, as you may know. Then we have the oats here with 13.5%. It's still in a range where we can work on. With rice and coconut, we are on the lower edge of the proteins. And interesting is here the fat content, especially with rice. You can see that we have only a little or almost no fats here. And this obliged us to use artificial oils in the formulation of the final milk in order to achieve as well a milk alternative with fats. Moreover, it is interesting to look at the carbohydrates. On nuts, they were relatively low, I would say, and especially with rice and oat, you have quite high amounts, so 58 or nearly 60 or up to 80%. And this is mainly fiber and starch. And this is also something to regard in terms of processing. We will also go later on more in detail. It's about starch network building during processing and how to avoid it. What you can see here is are typical formulations from non-clean label products and clean label products. So we can differ those two types. It's not a formulation from only one product. It's from a range of products. It can be every product. This is also why we have here these quite huge ranges. So we have a relatively high water content in order to achieve the same viscosity or come close to the viscosity from water, from conventional milk. Then we have 2 to 4% of nuts or grains. On the non-clean label product, we have as well added sugar up to 8% as sweetener. Then already claimed the artificial oil in order to have as well the oil content as nutritional value, the healthy fatty acids. And on non-clean label products, there are also emulsifier and stabilizer added. If you look at conventional milk, there is also emulsifier, but no artificial emulsifier. This emulsifier is naturally in the milk. It's phospholipids and different proteins. And with some of the alternatives, there is also a little bit of emulsifier, but in most cases, there need to be we need to be adding some artificial emulsifier in order to create a stable emulsion and to stabilize the formulation. Stabilizer can be up to 0.1% to create a certain mouthfeel. Vitamins and minerals less than 1% if the alternative, so the raw ingredient, has not sufficient vitamins or minerals. The customer can as well add artificial ones. Some flavoring is also allowed to get a optimized taste. What you can see here, the clean label, as I already mentioned, there is usually no oil, no emulsifier, no stabilizer used, but in consequence, the clean label formulas are naturally less stable. So the emulsion is less stable due to the low emulsifier content, and also it tends to sediment depending on the product. Yes, we talked about the recipe or the formulation one slide before, and what you can see here are raw material supplier which are specialized in recipe development, which can help you to develop your plant-based alternative. With some of them, we also already made some projects, and yeah, it is also possible to let's say have a project among the among us and among these manufacturers. What has to be stated quite clearly is that Proxys is not a formulation developer or recipe developer. We are a machine manufacturer. We can support you to find the optimum process, and these guys here can help you to develop the recipe. Looking at the manufacturing process of the plant-based drink, here you can see the whole manufacturing process, and we would like now to focus on the raw ingredient grain and nut. So for example, oat, rice, or different kind of nuts. And there's also the possibility to use flour, which is already pre-grinded or grinded dry, or to use a paste. Later on, I will show you some advantages and disadvantages of using these pre-processed products. But yeah, we will go further on with this explanation here. So if you look at nuts, already mentioned, it is possible to grind them without water by using different kind of mills. We process them also with some heat exchangers to bring down the heat, which is introduced during the milling. And finally, we would create a paste with a certain particle size. And if we go the other way and we will adding some water to it, we will create a so-called slurry. So water and nuts are directly dosed into the feeding aggregate of the mill, and then a slurry will be created. And talking about grains, so oats or also legumes like soy, it is not possible to grind them dry. We would always use water for grinding to create the slurry. So the slurry is a kind of suspension with a certain particle size distribution, and the paste is more viscous. It is also a suspension, but without water. It's an oil suspension. After the grinding, there is usually an enzyme treatment. Some of our customers are dosing also enzymes in the beginning before grinding together with the raw ingredients. And these enzymes, in terms of grains, for example, are there for the hydrolysis of the starch. You can imagine if you have a hot process, so if you dose hot water into it, into the grinding zone, and you have these oats or rice, for example, there will be an immediate creation of a starch network, which creates a quite high viscosity. And to avoid that, or to immediately destroy the starch network, enzymes are added, and this will also enhance the grinding effect or also the further processing, because it's not from advantage if we have such a thick mass for also the following processes. There are also special enzymes for adjusting flavors. Followed by the enzyme treatment, there is a separation. This is usually done in a decanter or a filter press. This is also up to the property of the product. And then we have an interesting thing that we have a side stream here in soy industry. This side stream here is called Okara. And the Okara are the fibers and the insoluble parts which were not grinded or not went into solution from the slurries here, but it has a quite good or substantial amount of proteins and valuable micronutrients. So it's a quite good protein source, and a lot of customers are throwing away, unfortunately, this Okara, or some of the customers are using it for animal food, but there's also the investigation or the need to further process that. We also experienced this with some other projects, that there is also, customers are also willing to process this further to other sources. So usually it will be homogenized or grinded, and then it can become filtration steps and further drying steps, and you can create, for example, a protein powder out of it, and then you can use this part here for other alternatives, or you can sell it to other companies. After the separation, there is the formulation step. I already mentioned there is a certain amount of emulsifier, sugar, stabilizer, like hydrocolloids, for example, which must be blended. This can be done, for example, in a vacuum processing unit with a rotostator system, where we feed the ingredients, where we disperse the ingredients, where we create a pre-emulsion. And for clean label products, it is usually a more simple unit, but most products are having these food additives. Followed by the formulation step, we have the so-called UHT process, ultra high temperature. This is for extend the shelf life, for preserve the milk alternative. It is done by a direct steam injection, for example, or indirect with tubular heat exchangers. Then there is optionally a deaeration step involved to remove off flavors, for example, or the moisture from direct steam, and to get less chemical oxidation. And then we have the high pressure homogenization to create this fine emulsion, done with a lot of pressure and a special device. Then it will be cooled and aseptic buffered. Proxys core competence in this processing is for sure the grinding module, And we would like also to go in the next slides a bit more in detail with the grinding procedure. Yeah, I already said the purpose of grinding is to transfer the plant-based product from solid into a pumpable suspension and to release the nutritional values as fat, protein, and carbohydrates, and also the micronutrients. And the reduction of the particle size has also a significant influence on the downstream process. It can increase the decantation yield, for example. And maybe if we step one slide back, you can see here in the separation, you lose always some good and valuable proteins, fibers, or also micronutrients. And if you have an optimized grinding on this end here, you would be able to have a quite valuable product and higher nutrients at the end. And this is also one fact here. If you compare make versus buy, so this means buy means you would skip the grinding and just buy the flour, for example, or the paste, which is already pre-processed. This means it is a lower initial investment for sure. They can be blended in the formulation step with water, for example, but the costs for flour is approximately 2 times higher than the kernels. And the cost of the paste, for example, is 1.2 to 1.5 times higher. And compared to buying the pastes, if you consider making the paste, there is also no control of the raw material quality, because you get what you get in terms of particle size, for example. And if you have the grinding process, you can very well adjust the fineness with the different process parameters we will later on discuss. For sure, there are lower costs of raw materials already mentioned. It is a higher investment for sure. It is a grinding module which has to be purchased. And we have a higher nutritional value compared to flour, for example, because flour is also a pre-processed powder, which already experienced heat treatments. And this would mean you would need to add more artificial micronutrients, for example, to your milk instead of doing the paste from the grain or the nut. As already mentioned, there are 2 possibilities to grind the nuts. Nuts can be grinded without water. Therefore, it is necessary to have moisture below 2%, so they must be roasted. Additional advantage is that you can store this intermediate product over a long time. There is a low microbiological risk of spoilage because there is almost no water inside. It is a cooling step necessary due to the heat introduction. So, for example, with a scraped surface heat exchanger. Compared to grinding with water, if we are considering the pure nut throughput, it is more. And it is a blending step necessary. Grains and soy, for example, cannot be grinded dry with our technology. Grinding with water, this is independent from the moisture content. So we can also process raw nuts. If they are unroasted, we just need to add water to it in order to be able to get a paste. Potentially, we may also a higher nutritional value and final product whilst grinding with water due to the direct contact and solubilization during the grinding process with water and the paste. It is an easier machine cleaning with water. This is for sure the case because the nuts, if you have a nut grinding line, it is usually the case that you need to clean it with oil instead of water, because if it would come in contact with water, you would create a massive viscosity and it would be taking a long time to clean. And here we are obliged to use first oil for the flush, and then we can use detergents. Disadvantage of grinding with water is for sure that the products needs to be processed immediately due to the high water content. We cannot store the slurry like the paste. And yeah, this is fact. This here should show you the impact on the particle size reduction, so on the particle size distribution, the impact of the different parameters which you can see here. First of all, the type of raw material is important. Different types are different, requires different technology, and are also yeah, easier or harder to grind, in easy words. The state of the raw material is important. If it is a whole kernel, for example, or is it already a pre-cut kernel, or are we talking about flakes, for example? Rolled oats is an example. And this all influences the final particle size. Also the adding of enzymes in the beginning. If you think about the starch network, what I told you, if we are able to release it, it is a more, let's say, fluent process in the mill. The temperature of the water has an influence. Also with regard on the particle size, usually the higher the temperature, the better is the size reduction, but there are also some limitations, especially regarding the starch network, which is building up. Then the ratio between water and dry material, usually it is, the grinding would be more efficient if a lower amount of water will be used compared to a dry ingredient. It will be more efficient then. And soaking and cooking time. For sure, we can soak the ingredients before grinding. This would make the kernels softer and consequently also in most cases more easier to grind. But in some cases, it's also not beneficial to soak them. Technology, here we are talking about the grinding equipment, the type of a mill, and if it is a single stage process or a multiple stage process with different kind of technologies combined. And also quite important are the settings of the different grinding modules, like peripheral speeds or grinding gaps. Residence time, this has also a quite large influence, a quite big influence. This is modified by the throughput. How quick do you pump your product through the grinding technology, through a mill? And the lower the throughput, usually the more residence time we have, and the more time in the mixing chamber of, or the grinding chamber of the mill we will achieve. And this means we have a longer contact time and a potentially better particle size reduction. The definition of the residence time is usually the volume of the reactor. In our case, it's the grinding chamber divided by the volumetric flow rate. Okay, this was my first part. I hand over to Lubos.
Thank you, Mark. Enjoy a short break. So in a Process portfolio, we have multiple technologies for particle size reduction. Here on the slide, you can see they've been organized in the properties from technologies of coarsest grinding to the finest. So on the left side, starting with a perforated disc mill, then further to the right, we have microcut colloid mill that can perform better job, and then when even larger size reduction is necessary, then the consecutive technologies are applicable. By a rule, with increased reduction, the throughput of the machines goes down. So that is portrayed here above the machines, each technology. So when we perform coarser grinding, the throughputs are higher, and then with reduction being stronger and leading to finer particles, the throughputs of the machines go down. So Mark mentioned the technology, so individual mills can be used in single or multiple step grinding. And it's important to make the right choice when it comes to in relation to application, especially which is the then optimal first grinding step, optimal second grinding step, and to configure the technologies to perform at the best rate. And so imagine situation within now related to the plant-based products. You start processing product that has an in-feed particle size of maximum 5 centimeters. For that grinding, we recommend first 3 technologies here highlighted in the dark green, which is perforated disc mill or microcut or colloid mill. The corundum stone mill can, under certain circumstances, process such a size of particles, but would not perform to its best. In this case, the cobalt mill is excluded as it can't handle such a size. The second situation is you have already maybe pre-cut or slightly pre-processed product, which contains particles maximum up to 1 centimeter. We would refer to it as a fine grinding, and in that case, for such a size, corundum stone mill can deliver the best performance. But also, if you already have in the process microcut or colloid mill, these 2 technologies are almost adequately same. The cobalt mill, similar as before, can't handle such a size and the initial size, and then the perforated disc would not deliver the optimal performance. And then the last case is we have an in-feed particle size of maximum 500 microns or micrometer. We refer to it as the finest grinding, and for such a particle size, we would go with cobalt mill technology, which is bead mill technology. Alternatively, the corundum stone mill can be used as well. When it comes to products with fibers, depending what is the expectation or requirement to reduce the size of fibers. So if the fibers have to be reduced down to a size that will make the fibers not visible anymore, then the corundum stone mill is the most optimal. And if it is just a partial reduction, then on the left, the technologies in the light green would apply. So in general, to summarize this part, the choice of technology depends mainly of application. And then the further factors also mentioned by Mark, the throughput that is required and the desired final particle size then determines which to go with and potential which combinations of grinders of these mills to choose. As we bring certain amount of energy into the product during the cooling, during the milling, the cooling as a downstream process can be also of requirement to maintain the constant temperature of the product or certain maximum temperature of the product. In our portfolio, we have a a tailored product, Tylotherm, which is a scraped surface heat exchanger. And this kind of heat exchanger is the most suitable type of exchangers for cooling of viscous pastes. So if you are supplying the process paste, or you using it in your process, this technology is the one to go with. If you want to temper already fermented milk alternatives, the scraped surface heat exchanger has advantage of very low shear forces, and so it does not destroy the product. Maybe less known fact. And under certain circumstances, a direct heating of the product is not possible. We'll see in later explanations from Mark that the overall processes, and so in that case, we highly recommend using this kind of technology. So Mark, I would like to hand it back to you.
Okay, thank you, Lubasz. So now we are going a bit more into practice. So we would like to present you some best practice lines in terms of grinding these alternatives. Yeah. We would like to start with soy, oats, and rice. This is a line where you will be able to grind soy and oat with water. Usually it contains, on the right-hand side, you can see a process flow diagram, and usually there is a direct in-feed via a volumetric screw feeder, or it can be also a continuous cooker. I also experienced this case also in one of the commissionings I did, and a direct dosing of water into a feeding aggregate. It is a hopper pump. You can see it also on the left side. So a hopper pump is typically a pump which has a hopper, like the name, plus a feeding screw beneath the hopper. And here on this end, we have a kind of eccentric screw pump. And then we will feed the product in line to the first grinding stage, which is in this case the perforated disc mill. Here we get a pre-grinding, and after the pre-grinding we will reach the fine grinding, which is the colloid mill, MZ. And yeah, this execution here is proven to be a very nice and good combination for soy and oat with a relatively high throughput. So we have lines up to 12,000 kilogram per hour available, and also with inline cleanability. This is also an important fact. In terms of final particle sizes, if you consider a particle size distribution, we can see a D90 value between 300 and 600 micron with this kind of technology. The next slide is showing a so-called multi-purpose grinding line. It is multi-purpose because on internal studies and also from customer feedback, we experienced that there are some difficulties if it comes to more complex products or to a quite large flexibility. And to overcome this, we invented this execution here. And with this execution, you can process a wide range of different alternatives. And the reason why we did that is mostly due to the risk of sedimentation for the several products like rice, or for example, also nuts. And there is the solution with the inline feed, the feed pump is not anymore suitable, because you can create, I go one step back, for example, blockages due to sedimentation in this pump or also in the pipings. And especially if you work with hot temperatures, starch networks can be built up, which can block also the mill or also the hopper pump. And this is why we recommend for these kinds of products, especially rice, this execution. As Lubaš said, the technology is dependent on the application. And here, if we consider rice, for example, we would use rather a colloid mill for pre-grinding instead of a perforated disc mill. This will give us a improved grinding or improved coarse grinding. We can also regulate the grinding gap with AMZ. And basically the difference here also is the vertical execution. We have a feed hopper with a feed screw, and the products will be fed into this hopper. And beneath the first grinding zone, there is an intermediate pump which regulates the throughput and also the level inside this hopper. And then as fine grinding, there is the possibility to use a second colloid mill, or if the requirement on particle size is even lower, and then a corundum stone mill is also possible. What we can see here on the right bottom side is a CIP execution of this hopper, so it is also zippable. Now we would like to show you a video clip from the previous slide, or it's related to the previous slide. It will show you the multi-purpose grinding line. So be aware, we have here also some music on this clip, and enjoy this clip. Okay, this was the video clip. Again, so on the next slides, we will talk about nuts and seeds, and also about coconut. And it's a surprise. It's the same. It's the same execution like the multi-purpose one. As I said, This is quite a flexible execution. It is also possible to grind here the different types of almond, cashews, or for example, coconut with this one. And I don't want to go further on in detail on this slide. This is something new. I already explained that it is possible to grind nuts without the addition of water, what you can see here. On the left side, you see raw material handling. It can come from a big bag station. It can be as well a silo. And then we would have here kind of feeder, which feeds directly into the first grinding stage, which is usually a mill from Freimer Kuruma. It can be a colloid mill, MZ, or it can be, if the particle size should be smaller, it would be a corundum stone mill. And as alternative, it is also possible to use the Stefan microcut. The choice of technology mainly depends also on the required throughput and also on the final particle size which is desired. Coming to the first grinding step here in the mill, we would process the roasted nuts, for example, to a pumpable paste with the output fineness depending on the nut for sure and on the quality of the nut in the range of 120 to 60 microns in one passage. And then there is a buffer tank and a positive displacement pump, which pumps the product to the scraped surface heat exchanger for cooling. And then it can be stored in a buffer tank, for example, for further processing. Or there will be a second grinding. With the second grinding step, we can reduce the particle size even a bit more from approximately 120 micron to 70 micron to until 50 to 40 microns approximately. And then there is an additional cooling step. And if you choose, or if you want to even grind the paste below 30 micron, below the below this value here, and then there's the possibility to use our bead mill technology, which is the Cobalt mill. It is also quite well known in chocolate industry. So you will not taste any particles anymore on the tongue. You are below this this natural border here, which is in most cases 30 to 25 micron. And using the scraped surface heat exchanger is not only for cooling. If you only produce peanut butter, for example, it is also for controlled crystallization of the fats. In order to have everywhere in the bucket, for example, the same structure. Okay, the grinding without water. There's also a little video clip we would like to present to you. Okay. Next slide is a kind of summary of the last slides. So I will just go through briefly. This I already mentioned here, the nut grinding. Coconut flakes can be grinded also dry if the moisture is below 1.5%. Coconut flesh should be grinded with water. Soy milk for industrial scale, ML and MZ. For small and industrial production without SIP requirement, also other combinations are possible. And Proxys is not the partner if you want to grind those products or rice and oats, so grains, without water. This will not work, unfortunately. Other dairy alternatives. On the next slides, we are focusing on the yogurt and ice cream alternatives. Again, we have little definition of the two products. The classic product, dairy-based yogurt, it is usually a fermented, prepared food, fermented milk by added bacteria. Mostly it's lactobacillus. And due to the bacteria, there is a creation of flavor and also a decrease of pH value. And due to the decrease, there is a creation of a structure coming from the proteins, the coagulum. And if you have a look at the right side, the plant-based ones, they are from different types of raw ingredients, which I already introduced you to, and they can be as well fermented by bacteria, but they will not build up this structure without adding any additives. So here again is the case, we need to add something in order to achieve the mouthfeel and the structure which is comparable to the classic product. This is the manufacturing process. This is one of the manufacturing processes. There are also others, but here you can see that we have again the grinding, which can be part of the process from whole nut and whole grain, already introduced you to. You can use, if you are a milk manufacturer, for example, you can use also the vegan milk as raw ingredient. So then you do not have any grinding. It is possible to use nut paste, but if you use the nut paste, it should be a quite fine nut paste with a particle size which is close to the 30 micron in order to avoid any sedimentation and also to be able to process it in a high pressure homogenizer, for example. And you can use as well some powdered protein sources. After this pre-processing step of the natural ingredients, the plant-based ingredients, there is the blending step again, similar to the milk blending. We have emulsifiers, sugar, water, stabilizer, and texturizer. It can be as well starch, hot swelling starch. It can be some hydrocolloids, sugar as sweetener, and emulsifier. And the process is usually the feeding, the blending, preheating, and pre-emulsification. Then there is optional the possibility to high pressure homogenize the mass. If you use already vegan milk, it is not mandatory. After the homogenization, there is the fermenting step taking place in fermenting tanks, for example. And as already said, the structure will not be created during this step. It is the step before where we add the stabilizer. It's more for having a culture inside the product and also for flavor reasons. Then a heat treatment will be applied especially if the yogurt must be stored under ambient conditions. It is mandatory. and after the heat treatment, there is a quick cooling usually. And next to it, there is a further mixing step. If you want to add heat sensitive flavors, for example, or fruit preparations, you can add them there. Important is after heat treatment, everything must be as hygienic as possible. So aseptic processing is the key word. So the fruit preparation can be bought, or it can also be manufactured inside. And then there is the aseptic buffering and filling. Talking about ice cream, we have here on the dairy-based classic ice cream product, which is made out of cream as base or milk and contains various ingredients like emulsifier, water, sweetener, stabilizer. And from physical point of view, it is a three-phase system, which contains oil, water, and air, which is consequently then frozen and stabilized. Compared to this, we have again a similar definition. It is the same raw ingredients like from milk or from yogurt, but most common is the use of plant ingredients which already have a substantial amount of fat in order to achieve the creamy and smooth structure, which is similar to the classic ice cream. This can be a production procedure. Again, we have the pre-processing of our raw ingredients or ready-to-use ingredients here. And the formulation step, it's similar to the yogurt process. It is a quite liquid product at this stage. We are adding the different ingredients. Then there is a heat treatment usually to have a preservation, a high pressure homogenizing, cooling, and then we have the so-called ice cream base. And optionally, again, for heat sensitive ingredients, which are not for the, or for ingredients which are not designed for the high pressure treatment, like particles, pieces, for example, we have a second formulation step where we blend all these ingredients, and this has to be as well as hygienic as possible. This is followed by a freezing and aerating step. So usually it's a continuous freezer where continuously air will be introduced into this mass in order to increase the volume of the product to make it a bit more fluffy and creamy. Then at the end, there's the filling procedure. Lubos, do we have some time for this poll here, or what do you think?
Yes, just I'll quickly explain, and we'll carry on with the slides that we have prepared. So as a next to slide, so quickly involve you, audience as well. We would be interested to hear from you what are the main challenges that you are facing in processing of plant-based products. So the predisposition is that you already started either experimenting or manufacturing some of the products. And so it would be interesting to us to hear from you what are those challenges. In this case, we have no interactive poll prepared. You can enter your input remarks directly into the chat, or alternatively into the question and answers function of this of the Zoom. When we, if you have enough time, we'll get back to this to spare some comments on that as well. Otherwise, we'll carry on now from now on, and you have time to at the leisure enter it into the chat. So Mark, okay, word is yours.
The next chapter is about process solution with focus on the two processes I showed to you. So the ice cream process and the yogurt process. And mainly we would like to talk with you about the multi-processing units. this can be as well implemented in these processes. Beside the grinding, Proxys has also multi-processing units in its portfolio. I would like to briefly introduce you to each machine and what main features the machines are having and for what purpose they are. So on the left side, you can see a vacuum processing unit from Prima Kuruma. It is the MAX-D technology. It is known for excellent emulsion quality. It has a rotor stator system. On the bottom of the vessel, it's a homogenizer which can create finely dispersed emulsions. We can disperse powders. So with integrated vacuum system where we have a direct infeed into the homogenizer, a circulation stream, a scraper agitator system, we can heat, we can cool. Next to the MAX-D, there is the universal machine. The universal machine is known for its easy processing and also for the knife system, which is inside this bowl here. So this has the advantage that we have a grinding effect on this machine. And another point is the fully tiltable vessel. So you can process also quite high viscous products and discharge it with tilting the vessel. This machine is as well a vacuum processing unit. It is able to heat, to cool your product. It can create as well dispersions. It can disperse powders and it can create emulsions. Next to it, we can see the VMC from Stefan Machinery. This is also a vacuum processing unit, a multi-purpose one, and this is known to be a good solution for recipes containing a huge amount of particles. For example, frozen goods. You can easily dump them in with the lifting device. The lid here is fully openable and you can add the particles quite convenient. There is also a rotor stator system involved, similar to the microcut system, where you will be able to form emulsions or to disperse particles. On the right side, it's contrary to the three processing systems. You can see an inline homogenizer, the Prima Kuruma DIL, and this can be implemented on current customers' installations, for example, to improve the process. You can imagine if you may have a simple vessel with a slowly running stirrer, it would take some hours to create a good dispersion in terms of thickening agents, for example. And to improve this process, this high shear rotor stator system can be implemented on existing equipment. Now we will investigate on which steps we can use what kind of machines. This is the yogurt process already introduced you to. So the first formulation step, if you can remember, this is about preheating, pre-cooling. It is about blending powders and dispersing, creating a pre-emulsion. And therefore, the MAX-D technology is the most suitable one, where you have the direct infeed into the homogenizer. You can see it on the left side. This is the principle. You will feed the ingredients directly into the mixing chamber. So first of all, there must be a liquid inside for sure, but then you can feed it directly into this mixing chamber here, premix zone. Then the product enters the dispersing and homogenizing zone. And at the end, there is a pumping impeller, which pumps your bulk into the circulation line back into the vessel. If you have an existing tank for this, if you already produce maybe this kind of yogurt or maybe also natural yogurt and you want to disperse, for example, thickeners and your vessel is not sufficient enough, you can use also an inline homogenizer. As I said, these are multi-processing units, so we can also combine several process steps. in one unit. Before, we were always talking about modular processes. This is the best way to produce highest outputs, highest throughputs. But we have also customers using the MEXD, for example, for the whole process of formulation, so blending powders, for fermenting. So high pressure homogenization is not possible, but some of our customers also do not do this here. It depends also what kind of raw ingredient you will use. And but yeah, they use it as reactor for fermenting. We can control the heating and cooling. So we control in a range of plus minus 0.5 degrees C. If we use water in the double jacket, for example, on external heating cooling unit, we can for sure have a heat treatment to stop the fermentation. There's a cooling function in this unit, and also there can be a transfer of the food preparation over there. This is typically for smaller or mid-sized companies who in the first phase would like to invest in a all-in-one solution. If we go one step further, we have also processing units where you can combine grinding and blending. This is the Stefan Universal Machine, as you can see here. It has rotating knife, which rotates with up to 3000 RPM, and it can also grind our nuts or grains coarsely. So it is a coarse grinding, and with this coarse grinding, you would definitely may need an additional mill in order to achieve a finer product, but we can combine also these units. It is thinkable to have a combined process of the universal machine, for example, and the corundum stone mill in order to get the most process steps out of the yogurt process. Already mentioned the Vacutherm system. It is good for manufacturing of the fruit preparation due to its large heat exchange surface, the ability of adding strawberries or other frozen stuff into the mixing device. And it has a rotor-stator system, which you can see here on the left side, which can also finely disperse things, but it can also be bypassed if you, for example, want to preserve these strawberries, for example. Looking at the ice cream, this is more or less similar to the yogurt process, so I don't want to get too much in detail here on this one. As you can see here, the heat treatment, the inline homogenizer will go away in this slide. The reason is the inline homogenizer does not have any heating function. So either your vessel is heated, then the inline homogenizer would be an option for combining those two process steps, or it will not work. But with a processing unit, again, you can combine these steps. And this is the same story, like I already told you. And the second formulation step, where you add heat-sensitive ingredients, can be also done by an inline homogenizer, which is connected to an tank. These are just some examples. This is a modular concept of plant-based yogurt process. What you can see in the beginning here is our vacuum processing unit MEXD. It processes the different powders and liquids into a into a mixture, and it's a modular concept. That means the fermenting is splitted, so we have optionally the high pressure homogenizing, and then the fermenting and fermenting tanks, a buffer tank, And from there on, it goes through a scraped surface heat exchanger for heating, so for stopping the fermentation, and to pasteurize the product to extend the shelf life, and then further to the cooling, which is also realized by a scraped surface heat exchanger. As Luboš already mentioned, this heat exchanger is very gently to the product's structure, and this is also why it is used in these kind of applications. Yeah, it's a modular concept for higher throughputs. Here you can see the ice cream process as an example. So by adding a vacuum processing unit, it can be a MaxD, or it can be as well a universal machine. If you want to have a pre-cut function, then it can be further processed with an MK in order to achieve finer particles. And then there is a downstream process which is not the scope of Freymack-Kuruma, but this is only to show what is happening. It's the pasteurization and high pressure homogenizing and the cooling. And for heat sensitive ingredients, like I said, it is possible to use an inline homogenizer, existing vessels, and disperse the ingredients over there. At the end, we have the continuous storage tank and the continuous freezer, which is also not in the Praxis portfolio. Okay, recommendations. I think we can make this as well, only short. For startups and small size companies, it's a good idea to start with a multi-processing unit as all-in-one solution, or using also pre-processed raw ingredients like ready-to-use milk, paste, or others. If the demand of the products become higher, the market demand, your demand, you can lowering the cost by processing the plant-based ingredients with grinding equipment from Praxis. In the beginning, I made a comparison between buy and make. And yeah, gentle heat treatment with the scraped surface heat exchanger will preserve the structure in a modular process. For ice cream, it is more or less the same. So I think, yeah, the last point maybe, the integration of Praxis equipment, especially mills and inline homogenizer, can allow customers who do already conventional ice cream to go also into the field of the plant-based alternatives. You are invited to come to one of our process and technology centers for doing feasibility trials, or to visit our real-life seminars around the globe. So our headquarter in terms of technology center is Praxis Neuenburg in Germany. There we have almost the whole Praxis portfolio available for trials. So you can send your raw ingredients together with your idea, and we will perform a feasibility study together with you. You will get a detailed report, recommendations, and you can test out your recipes over there and define a process. But not only in Germany. So we have also the site at Stefan in Hamelin. There is mainly Stefan equipment, but we have also around the globe some other facilities like Mundelein, Illinois, in the US. In Singapore, there is a technology center, or the newest one here in Shanghai. Yeah, I think so far it is everything from my side. Luboš, I think you can go further on with the last slide here. Luboš, are you sleeping?
Yes, I said sorry, my microphone was muted. Okay. I had a quick nap. We are slowly but surely approaching the end. Basically, that this is the last part, and I have 2 more informations for you, just from more organizational point, just to bring it forward. We had several questions coming in. I would like to, yes, one has been already answered from Mark. In the meantime, you're multitasker. So the first question, will this plant-based be called yogurt or ice cream? In few countries, it is called dessert and not ice cream.
Mm-hmm.
Mark, how is your experience? What would you?
I'm not a lawyer, to be honest. So different countries have different rules. And I'm, to be honest, not quite deep into this topic. So I have to investigate this as well. But I can imagine, I know that it is in the European Union, it is the case that that milk or that milk alternatives cannot be claimed as milk. So I can imagine that the same will count also for ice cream or yogurt.
It is a possible scenario that later, sooner or later, there will be more initiatives to avoid possibly misleading or using this naming. In my opinion, from my side, from my knowledge, is more the marketing based, and I know that for example in Europe the term dessert as a frozen dessert is more like a general naming of the products, inclusive ice cream that you can find in the stores. If that will be the case, then for the plant-based, we'll see. Another question, I presume it relates to the manufacturing cost, and it is how is the cost per liter of animal milk against plant-based milk? Mm-hmm. For my experience, as talking of the region where we are based, the selling, so the retail selling prices are not as far apart between the animal and plant-based milks. So far, I haven't investigated how is the manufacturing cost, especially of the plant-based milk. Mark, your opinion? Do you have any?
I can just
indication.
Say something from my experience if I go personally to the market, so not the manufacturing cost, but the market cost. And from my point of view, the plant-based milk is more expensive compared to animal milk. So animal milk in Germany, you can get it for 50 euro cent, for example. And the plant-based alternative is, from my experience, around in a range from 1 to 3 euro per liter.
Exactly. Yeah, I share your opinion as well. It also depends on the protein source that is used for the plant-based milk in this case. Okay. The next question relates to the shelf life. And the participant is asking of this webinar, how is the shelf life of plant-based UHT processed milk?
Yeah, I have to be honest, I don't know exactly the shelf life of a plant-based UHT processed milk. It can be, from my technological understanding, be comparable with the animal milk, because we have also the same, more or less the same heat treatment during this procedure. But yeah, I have also to have a look or to investigate. Yeah, as you know, Proxys is famous for the grinding technology, and we have also the multi-processing units. But especially for liquid products and UHT processings, we are not the experts. But we have a UHT processing for processed cheese, for high viscous products in the Stefan portfolio. But this is something different.
Okay. I have a couple of more questions here, but I believe I will answer those in the following slides. So if there is no upcoming,
please feel free to ask more questions.
Yes, if it's okay, I'll carry on with my explanation, and hopefully, if we see another question coming in, then we'll answer it straight away. So, just for information, after this webinar, you will receive a short email with request for a little survey, especially on concerning this webinar, and part of that email will be also a link where you can download the slides of this presentation. If you would like to have access to the recording of this webinar, please get in touch with us. I'll mention the email address on the next slide. Before I'll jump into that, if you feel you want to share opinion with us straight away, you are free to do so. So if you would like to leave us a remark, comments on what did you think of this webinar, or any suggestions for the next sessions, you're more than welcome to do so straight here in this webinar. So here, the mentioned email address, for those that haven't been at the beginning when I spoken about the webinars already in this call, I would like to just repeat this information. We have multiple webinars ongoing since, in this case, since this year, concerning diverse topics. For those that missed the webinars, please drop us an email to email address events@proxys.com, and we will grant you access to the recording. For the webinars upcoming in September, October time, you are welcome to register at our website. Possibly you will find the information and get redirected to the website over LinkedIn. And then if you have a chance to come to Germany, to the test center, we have in October, November time, 2 upcoming seminars, which are more intensive, go over several days, consisting of theoretical and practical part. In this case, there will be a seminar on topic mayonnaise, ketchup, sauce, mustard, and then in November time, processed cheese, vegan and its vegan alternatives. So that was the information that I had as a last. One more time, the email address where you can reach us is events@.com. Let's see if we had in the meantime any more questions. So if I say it correctly, Mark, correct me if I'm seeing something. The questions we had open have been answered. And so I think, apologies for 11 minutes delay in our schedule. I hope you enjoyed the content. So at this point, I would like to thank you, Mark, for presenting the main part and sharing very valuable insights into this plant-based field, also contributing to the preparation with your knowledge and experience. And I would like to thank all the participants in this webinar for taking their time and joining in. I hope the content has been valuable, and looking forward to your inquiries or seeing you around for the next webinar. So thank you very much.
Yeah, also from my side, thank you very much. And have a good day.
Bye-bye. Thank you.
Bye.